absolutely welcome here by Tux. Some of you have never been on this absolutely gorgeous campus, and it's my privilege as Sarel van Greenen, aka Mr. VG, to welcome you guys. There we go, my pointer is working. To welcome you to the winter school for the junior Tux. It's an absolute honor and a privilege being here. And it really sucks that we don't do an Afrikaans winter school this year. I was very sad because I'm only going to have to teach like 2 hours a day. That's how much I love my job. Last night I called my wife and I said to her, I only have 2.5 hours or 2 hours to teach. What am I going to do with the rest of my day? I don't know. Okay? But welcome, one and all. This is going to be fun, for me at least, okay? And look, the reality is we only have 8 hours of maths this week. Only 8. Now, for some of you, that sounds like torture, but I promise you it's going to go by much quicker than you ever in your life thought it is possible. Now, to say this very clearly, I don't think 8 hours is enough. We only have 8 hours or 4 days. Good morning, miss. Please grab a booklet there. Make sure you grab one. Sir, did you get a booklet? Okay, that's all right. Okay, here's one for you. Okay. Now, ladies and gentlemen, with that in mind, I want to offer you guys something for Mahala. 2 things for Mahala. Number one, this booklet, which you won't find in any other, you won't find it in any bookstore because I wrote this myself. 52 pages of absolute pure heaven on earth. Okay? This is basically the theory you need to write matric maths. I've spent about 15 years, and I'm still working on it. I've actually updated it since I've written this one. Because I just love maths. Okay? I really just love maths. Some of the guys that know me there will know me that I love my maths. So this is the first thing I'm offering you for free. But so I paid for the week. Yeah, you paid for the week, but you're still getting it for free. Okay. Secondly, I would like to offer you guys the opportunity of saying, instead of doing 2 hours of maths, good morning, ma'am, please grab a booklet. Please grab a booklet. I would like to offer you guys to say, let's go for 2.5 hours. So, when we get started, you will see actually why. Remember, we only have 8 hours. If we do half an hour extra every day at the end of the 2 hours, so let's say, for instance, today ends then at 10:30, it's going to mean we have 10 hours in total instead of 8. So I'm offering that to you guys. So by 10 o'clock, we'll ask and say, those, let's stay behind for another half an hour, whatever. How does that sound to you guys? Good. Okay. Now, ladies and gentlemen, because we don't have 2 or 3 weeks, we can't go through the whole curriculum. I would love to. So what I've done is, this week is basically going to be consisted of kind of, can I say, a few parts. Like I'm going to tackle today, my focus is going to be on functions and graphs. Because I know you guys suck at functions and graphs, let's just be honest. Okay, I've taught long enough to know you guys suck at functions and graphs. But secondly, I am not just going to go and, I'm not going to reteach the whole curriculum. New perspectives on how to solve things in a mathematical way. So we call it, the very fancy term is mathematical reasoning, but it's basically just problem solving. So I'm going to share with you as we go along throughout this week, I'm going to share with you some techniques I've developed and over the course of the past 20 years on how do I solve problems. And I had an inspiration this morning, thank you Mr. Kutlwano there, who inspired me by a problem that he brought up this morning that he got in his June exam, that I'm going to do with you guys on the board this morning to illustrate the first type of mathematical reasoning. And the first type of mathematical reasoning, and please make as many notes as you can, is going to be called the monkey behind the mountain. Okay? Now the monkey looks as cute as this little teddy bear. Again, I wanted to find a monkey, but my beautiful 10-year-old girl only had a little rabbit. When you guys do homework sums and you prepare for exams, usually the questions look as beautiful as that. Looks cute. It's easy, sir. I can do everything. And then when you get to the exam, do you still see the monkey? And then you come to your teacher. Oh, sir, man, that test was impossible. I had no clue where to start. It's unfair. I heard that this morning as well. It's unfair. Now, it's not really unfair. It's just life. I promise you, as you grow older, your problems are going to get much bigger, and the solutions are going to be much more hidden. So today, and this is what I want you guys to start thinking about, is, see the monkey? This is now my monkey for the week. It's hidden away. Do you still see the monkey, sir? Exactly. That's the problem. So this is a technique, the monkey behind the mountains, is a technique I want to share with you on how do I approach to get around this monkey or around the mountains to actually solve the monkey. Just sit up, you bugger. Here we go. Got you strapped in here. Okay, there we go. Okay. So ladies and gentlemen, what do I mean by the monkey behind the mountains? The monkey behind the mountains is effectively asking a bunch of questions like, I'm going to ask you, let's answer that question. Now that is an easy question, an easy matric question. Yeah, grade 11 it was like, oh! Okay, determine the range of f of x. Okay, so, what is the monkey? Now you're like, what the hell do you mean? What is the actual question they are asking you for? So in other words, this is what the examiner is looking for. So if they ask you solve x, your monkey is going to be x equal to this or this. And then the kids get to x is this and x is this, and they go to the next question. They never actually answer the question. So what is the monkey in this case? The range. But what is the range?
The maximum y value.
Oh, maximum. Why not minimum?
Because it's a negative.
Ah, okay. So now I can think of the range as being y is an element of some minimum, some maximum. And what we've just highlighted to you is the mountains. You guys know the small company called Ernst & Young? She was one of the main HR recruitment specialists, or one of the HR specialists internationally. they've already put in place now the program for the next 5 years that they're phasing out all auditors because they're being replaced by computers. And that was even before AI. Hashtag just saying. We've got no clue what's coming next in the job market. Don't let that scare you, let it excite you, because the job that you dreamt of may not exist today. Hashtag just saying. So, what are the mountains? First of all, a minimum. Second, a maximum. Now we start thinking. And the gold nugget that I was talking about is the following. 60+% of first-year university students do not make it past Calculus 1. Why? Because if you look at the math toolbox, it looks either like this. Is there a lot in there or not? There's very little, and I've got a bit of sandpaper in there. I actually do have a pencil in here, believe it or not. I'm always looking for this pencil, but yeah. Or it looks like this. Sorry, but that is how my garage looks, but we don't talk about that. What is the difference between the two, and why is both bad?
One has nothing in it and one is too cluttered.
Okay, so there's one has nothing in it and the one is?
Too much.
Too much. The problem is, ladies and gents, I'm saying this now to you, and I think because of where you guys are now, hopefully, your toolbox doesn't look like this. I think most of you, your toolbox looks like this. Meaning, there's some stuff in there, but hey, you're gonna, if I'm looking for something in there, unless I see it first time, I'm gonna be struggling.
Or you just dump the whole thing.
Hey, you dumped the whole thing out. Can I tell you what's a problem? Next time I try and use it. Yay. Ladies and gents, this is not my words. This is a word from the professor, from a mathematics professor at the University of Stellenbosch. The two reasons why first-year students fail, 60% of them fail, and this was before COVID. Now it's even worse. Is either because maths is not a study subject, sir. I'm just going to practice, and get it right. Or I'm going to go through all of my knowledge every time I attempt a sum. And halfway through we give up because we don't have time. I think most of you are in that, where you at this moment after the June exams you kind of realized, I didn't want to say that. Okay, oh beep. Okay. So, first of all, you need to start filling your toolbox. You still have 6 months. Actually 5. You've got 5 months till matric, but you still have the rest of your life. You've got to start filling your toolbox. So you've got to start studying maths. Yes, you heard it right, studying maths. Secondly, you need to start organizing your toolbox. So I don't look at everything. I don't look at all graphs when I get a problem. I look, it's an x squared. So I look at what does that tell me? That tells me that it is a negative parabola, which means I already have the minimum. But if I'm looking for the maximum, that's the turning point. Or if you did all of you do calculus so far this year? Yes, if you didn't, you're going to struggle tomorrow. But I'll guide you with it because tomorrow we're doing calculus. So now you've got to start asking yourself the question, sir, what are the 3 methods of getting the stationary point of a parabola? But what, yeah, that is the same thing, yeah.
Point of the x values.
Okay, fantastic. Just stop for me for a moment. What is the first thing you said?
You can use the midpoints of the x values.
Use the midpoints of the x values. Don't forget about symmetry. Is there any of you that are in independent schools, IEB schools? Listen up. They love symmetry. They're going to ask symmetry, and I'll show you guys later on what I mean by that. Second method.
The turning point formula minus b over 2a.
Almost. X equal to?
Oh, x equals to negative b.
X equal to negative b over 2a, or derivative equal to? 0. So you've got 3 methods. So grade 12s, this is a challenge from me to you. If you go and practice your exams, do not be happy with just one method of solving something. Because you don't know what the examiner is going to ask. You don't know how they're going to ask it. So get 2 or 3 different methods. So I can go either negative b over 2a. There's a 4th method, so completing the square. Okay? Hello. Or get the derivative equal to 0. Because again, I don't know what is coming up. I don't know. So now, for me to get the x value, I can get the y value, which gives me my maximum, and I've got my minimum. Yes?
Can you not just use 5 as your starting point? As your y value? Because it's easier.
Where is that 5? No, where's the 5? Is the 5 there? Oh, kind of be careful, guys. The 5 is there, not there. Okay, that's fine. This is a safe space. I won't laugh out loud. I'm joking. Guys, we are all going to make mistakes throughout this week. So don't feel afraid of putting up your hand and being wrong. Yes, sir.
So for the completing the square, sir, wouldn't you need the turning point and then we'd be working out the equation rather than the turning point?
Say again, sir, for the completing the square?
Yes, sir. To use it, wouldn't we need the turning point?
No, you don't. You can remember that completing the square when it's introduced in grade 11, which is awesome, but really like what? It's unnecessary, but it's a way of writing something like y equal to negative x squared minus 2x plus 5 into the form of this, where I can then read off my turning points. Okay? I think it's completely unnecessary in algebra to be completing the square, but we need it where? Calculus, no. Analytical geometry. Have any of you done analytical geometry circles? You need completing the square to find the midpoint of the circles. But please, again, ladies and gentlemen, listen up. In first year and second year varsity, you're going to use completing the square in calculus. So please don't throw it away and go, I don't need it. You don't know what you're going to need or when you're going to need it. Don't be that arrogant. I was that arrogant and it didn't end well. It did not end well at first year varsity. So, go and get that monkey for me. Determine the range for me. Go for it. In any way, guys. Welcome to those who came a bit late. It's good to have you all here. Okay. So if I look at this, I can do x equal to negative b over 2a. So that's negative 2 over 2 times negative 1, which gives me x equal to negative 1. Okay, which means my graph is a little bit wrong here. Should be there. That's 5. So at x equal to -1, I've got my axis of symmetry. And then to get the y value, y is -1 squared minus 2 times -1 plus 5. So that gives me a beautiful 6, if I'm not mistaken. Okay? Which means my range is, thank you so much. Y is an element of my minimum, -infinity, my maximum of 6, doesn't touch, -infinity, but does touch 6. Okay? As easy and as simple as that. Now I know this is an easy example, but it is something that I would like to share with you, because when the going gets tough, like the one I'm going to show to you guys now, a series of circles are formed by multiplying the previous circle's area, not by 80%, my humblest apologies, by 81, not by 90, but by 81%. That's the one I'm looking for. By 81%. Determine the sum of the radii if this sequence, continues indefinitely. And the first circle has an area of 18 pi. I'm giving you guys 8 minutes. But what I would like you to do is take 1 or 2 minutes before you attempt it to identify the monkey, identify the mountain. So what's standing in your way of getting to that monkey? Now this is a beautiful 6 or 7 mark question for the exam. So go for it, ladies and gentlemen. Enjoy. Ladies and gentlemen, I can say this, I can see this, that a lot of you are still not really going towards the monkey behind the mountain. You're running into it head first. I love some of the attempts that I've just sampled throughout, and I love it. Please remember, ladies and gents, in your booklet, you've got a whole page of all the theory basically you need for sequences and series. This is on page 10. Now, okay, let's hit the pause button on your attempt for a moment. And I want to teach you, let's go through the monkey behind the mountain. If I look at this, it says here, a series of circles are formed by multiplying the previous circle's area by 81%. We'll come back to it. Determine the sum of the radii if this sequence continues indefinitely. Now that's a very important word. Although I am a mathematician, sir, I love my English. I actually love to blog and I love to write articles. I look at the word indefinitely and automatically it sparks something in my mind that I've got to remember. What does the word indefinitely mean? Infinite, forever. Automatically, I'm thinking S infinity A over 1 minus R. But so when can I use this formula? Yes, sir? Between -1 and 1. So please again, you cannot use this. Okay, sorry for writing it in this way. It's a bit different from what you guys are used to. Okay? But remember, and I have asked this in the past, sir, as an inside question where I give someone in an exam and I tell them, say there's a ratio of 1.5. And I tell that person decided to use S infinity and then they get to some ridiculous answer. And I ask them, why are they wrong? Then my kids freak out. But so you're asking me to write in words? Yes. I cannot use this formula unless R is between -1 and 1. Okay, so there's just something that pops up in my mind. The first circle has, so let's quickly get to this. What is the monkey? That is where I need to go. So I know that in the end I'm going to write for the examiner that S infinity is equal to something. Now, to identify the mountains, I look at the formula. What is the formula? A over, there's my two monkeys. A and R. So I know somehow I've got to find A for what? For the radii. Not for this area. And the same with, I've got to find R for the radii, not for the area. You've got to be careful. Now, some of you are going, but isn't it the same? No. Let me explain why. If I look at area 1, which is 18 pi, what will be the area 2? %, of 18 pi. What will be area 3? 81% of area 2. Please get this, I'm not multiplying the radius by 81%, I'm the whole area. So if I look at this first one, I'm going to bring in my formula. Pi r squared. I want this because that's going to give me my first area, or my first radius. So my first radius, R1, divide by pi on both sides. I'm sitting here with 18 equal to r squared. R squared is 3 root 2 r. Everyone is all right there. Now what about area 2? Because for me to get r, I need to take the second term and divide it by the first term. So I need the second term. I need the first r I've got. That is 3 root 2. So I need to find, and I'm going to do this, 81% times by 18 pi r2 squared, or that, is equal to pi r2 squared. Everyone is alright with what I wrote down on the board? Is there anybody that isn't? Please be honest. Put up your hand and go, so, oh, you're right. Okay. What I'm doing is I'm getting area 2. You with me? Area 2, we've got from here as 81% times by 18 pi. Now I can solve R2. Again, our pi's are going to divide away. I'm left with 81% of 18. Let me see if I can quickly get that. Is that going to be, wait, let me quickly, oh sorry, my maths is a bit slow today. 80% of 18 is going to give me 14.8. Is it 14.98? Please put in your comment. Oh, I was close. Sorry guys, sorry to disappoint you. Okay, 14.58. Oh yeah, I made a silly mistake there. Okay. So this means that R2 is the square root of 14.58. So if I put it in here, I've got the square root of 14.58. And that is my common ratio. And please tell me it's 0.9.
Yes.
Oh, so magic. So how did I know it's going to be 0.98? No? Please in your calculator put in the square root of 0.81. Oh my goodness! Ladies and gentlemen, how did I know this? Okay, number one, I'm really clever. But number two, ladies and gentlemen, if the ratio of area 1 to area 2 is 1 to 0.81, because it's squared, this is going to be the radius 1 to radius 2 is going to be 1 to the square root of 0.81, which is 0.9. Because I square the radius to get to the area. That's how I knew when you ladies were like, the area and the radius, it's going to be the same. No, it's not. You've got to be careful. But I just know some dirty old school tricks, okay? Is it fine if we do it like this? Yes, please do it like this. I need the ratio. How do I get the ratio? T2 over T1. So I need the second radius. I need the first radius. That means I can now substitute in, because I've got the first one, 3 root 2, 1 minus the ratio, 0.9, and you've got your answer. But the biggest problem I can tell you guys now was not that you couldn't do the sum, it's because very few of you planned your sum. Now actually, I didn't just employ one problem-solving method, I employed two. Can I tell you which two I did? I was sneaky. The first one that I did, ladies and gents, we call digging. Literally digging through mud. I first read through the information and go, a series of circles. Circles are important because it brings me to two formulas. Are formed by multiplying. There's another important word. That means I'm going to look at geometric series. The previous circles, so I know I'm not going to work with that. So I know I'm going to work with that. And I know that is going to be the R of the area, the ratio of the area. And just by looking at that, I've eliminated a lot of other nonsense that I don't have to look at. And miss, this is why they say first year students fail. Is because they don't do this. They don't do this. But sir, for you to be able to do this, your toolbox has to be organized. There actually has to be something in your toolbox. It doesn't help me telling you about circles and you can't even tell me the definition of a circle. Ish. Don't worry, a lot of teachers also don't know. Okay. But ladies and gents, more important than me looking amazing and doing the sum on the board is that you look at my approach. I first dig through all the information. Then I start going towards, okay, here's my monkey. But my monkey is hidden behind some mountains. Usually the mountains are in the formula. So now I know I've got to go and find that monkey. Find that monkey. And then I just run through, usually backwards, how to get there. And that says how I get 90+% if I do a maths exam. Okay, ladies and gentlemen. Okay. I'm loving the discussions. I'm loving the discussions. And please get this, ladies and gentlemen. I'm throwing out these kind of sums. You might never have seen it in your life. And that's the point. Because you've got no clue what the examiner is going to expect of you at the end of the year. IEB guys, get used to it. This actually I think comes from an old IEB exam paper. Okay, no wonder. Okay. Now ladies and gentlemen, whenever I get something like this, that is unknown, unseen, never seen it before I actually attempt it, and I tell this to my students, is you analyze what you've got. Okay? I do, the majority of my work is in analyzing. And you guys will see that's maybe a bit different from your teacher, because teachers suffer from something that they call the curse of knowledge. Now the curse of knowledge you'll realize when you try to explain something to a friend of yours. And I'm sorry to say the clever kids, meaning the kids that get 85 and 90 and above, are the worst teachers in the world. Michael, not you. You're all right, okay? Because the curse of knowledge is actually a psychological thing which says, when I try to explain something to you, I've got no idea what's going on in your head. And usually very clever teachers are the worst because they kind of look at you and go, how do you not get this? It's so easy. No, but, I won't say that on recording, okay? But maybe the physics teacher is watching. Okay. Now, ladies and gentlemen, if I look at this question, I constantly am asking myself, what do I have? So if I start at the top, doesn't matter starting top or bottom, my first coordinate is here right at the top at -5, 6. And that open dot means what? Not included. Okay, it's not included. It's a discontinuity for the further study maths class. Okay? Then it kind of goes down to there, to -3, 2. Then it makes this bubble here. And then goes down all the way to there. it passes through -5 and 0, and then at -3 and -2, it's there at the bottom, open dot here at 1, comma, -4. Now, what I love to do is, because they are actually asking me about the inverse, let me go and draw it. Go and actually draw it. But so they're going to ask me, I don't have a free. Yes, we don't have more than this, and that's fine, because if I draw the inverse, -3 comma -2, or -3 comma 2, becomes 2 comma -3, so somewhere there. That coordinate is, I know it's not on scale, so don't crucify me for this, 6 comma -5. So I know I've got to connect those. Then this one goes through 0 comma -5. That one goes through -2 comma -3. And it ends up at -4 comma 1. And there I've drawn the inverse. Okay, just swap everything and go. Okay, so give the domain and the range of f. So now we're talking about f. Again, monkey, domain x element of, range y element of. The minimum for y, or let's start with x, -5, and sorry, it does touch it. It does touch it. But so it doesn't there, but it touches it. So I include it. Up to, what is the maximum? The furthest? 1, but that one it doesn't touch. For y, minimum is -4, maximum 6, doesn't touch. Don't overthink it. Now, determine the value of f of -1. I know it's going to sound stupid, but what does f of -1 mean? Say again, yes, ma'am? Okay, just f, not f to the f. Just f of -1. What does that mean? No. We are missing the point. First of knowledge. I'm asking, what is f of -1? Say again? Okay, so, and please get this. This is important for tomorrow. You've got to know, there are 4 notations, and all 4 notations you've got to know off by heart and what it means. F means y value, so position. So this is the y value when x is -1. I'm saying this is important because tomorrow we're going to work with f accent and f double accent. And then you've got to know, and we love to ask, especially in the IEB papers, mix it all up. I've seen them actually ask 3 notations in one sum. Okay? I'm that kind of a teacher. So what is the y value when x is -1? When x is -1, so there, and I'm reckoning I can read it off -3. Now, f to the -1 of -2, what does that ask me? Say again? Okay, you're making it very complicated. The x value when y is negative 2. Because remember, f to the negative 1 means x and y swap around. So if I go f to the negative 1, it is the x value when y is negative 2. Where is y negative 2? At negative 3. When y is negative 2, my x value is negative 3. Or, if I've drawn the inverse, then I can say it's the y value when x is negative 2. And that is negative 3 in any. But what am I to do with this? Multiply. So the answer is 9. Now the question comes, would f to the negative 1 be a function? Now, this is why I wanted to draw it. Because now I can say for sure, it is. Why is the inverse function a function? Or the inverse graph a function? Why? Unfortunately, that's not actually a reason for something to be a function. Yes?
For every x value, there's only one.
For every x value, there's only one y value. That's the only thing that you could ever use. And please, saying it passes the vertical line test is not a valid reason. Did you use that? No, I'm hoping not. Okay. Remember, ladies and gents, the vertical line test is just a nice way of seeing it, but not a valid way of explaining it. For every x value, there's only one y value. Now, for which values of x will the inverse be decreasing? That's why I drew the inverse. Because looking at the original and then they're asked about in, that's fine. From here, all the way to there, and then again from there, all the way to there. That's why I drew it. So it's going to be for x between, this is negative 4 and 0, decreasing, so I'm just going to go like that. And then or from, what is this coordinate? I think it's at x equal to 2 up to this one here is at 6. 2 to 6, there and there. Is there any further study maths, guys, in the class? A few of you. Okay. Why is the inverse not differentiable at this point? Why is it not differentiable? Those of you that don't have further studies, just smile and wave. Why? Come on. Oh, someone has to do some studying before the exam. It's because the gradient on the left is not the same as the gradient on the right. And what does that mean, sir? And what does it mean? And what does that mean? It means I can draw infinitely many tangents to that point. There's not just a singular tangent I can draw to that point. Woo, sir. Hey. Yeah, some studying left before the exam coming up. Okay, ladies and gents, it's already 9:22. Please take a 5-minute break. I want us to start again at 9:30 for the last little bit. Okay? We are going to from now on, I'm going to do a lot less talking and you're going to do a lot more doing. Because I've got about 2 or 3 beautiful questions that I got from previous exams that is going to stretch your mind and make you think.